Alright, so in this video, I'm going to solve an interesting system of equations. So for my first equation, I have x squared minus y squared is equal to 40. And for my second equation, I have x times y is equal to 99. So now I'm going to solve this system of equations by finding the value of x plus y. So this is my goal here. What is the value of x plus y? So let me first start with equation 1. So for equation 1, I have x squared minus y squared is equal to 40. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So x squared minus y squared is equal to x plus y times x minus y. And this is equal to 40. Now from here, what I'm going to do is square both sides. So I have x plus y times x minus y squared is equal to 40 squared. Now x plus y times x minus y squared is the same thing as x plus y squared times x minus y squared. Now if I have something in the form a plus b squared, this is equal to a squared plus 2ab plus b squared. And if I have something in the form a minus b squared, this is equal to a squared minus 2ab plus b squared. So I get x squared plus 2xy plus y squared times x squared minus 2xy plus y squared is equal to 40 squared, which is 1600. Now I'm going to let x squared plus y squared equal to m. And I'm going to let 2xy equal to n. So now I have x squared plus y squared squared minus 2xy squared is equal to 40 squared. Because, let me just go back. If I substitute these values in, I get m plus n times m minus n is equal to 40 squared. And m plus n times m minus n is m squared minus n squared. So now, if I substitute these values back in, I get x squared plus y squared squared minus 2xy squared is equal to 40 squared. Now, remember how x times y is 99. So if x times y is 99, we have x times y over here. So I'm just going to go ahead and plug that in. So now I have 2 times 99 squared is equal to 40 squared. And now if I add 2 times 99 squared on both sides, I get x squared plus y squared squared is equal to 1600, which is the value of 40 squared, plus 39,204, which is the value of 2 times 99 squared. So now if I add these two, I get 40,804. And now if I take the square root on both sides, I have x squared plus y squared is equal to positive negative 202. Now, if I have something in the form a plus b squared minus 2ab, this is equal to a squared plus b squared, because a plus b squared is equal to a squared plus b squared plus 2ab. So if I subtract 2ab from this, all I'm left with is a squared plus b squared. So this means that x plus y squared minus 2xy is equal to positive or negative 2 under 2, because x squared plus y squared is positive negative 2 under 2. So if I subtract 2xy, all I'm left with is positive negative 2 under 2. So this means that x plus y squared is equal to 2xy plus or minus 2 under 2. Now again, recall that x times y is equal to 99. So I have x plus y squared is equal to 2 times 99 plus or minus 2 under 2. And this is equal to 198 plus or minus 2 under 2. So this gives me two equations. I have x plus y squared is equal to 198 plus 2 under 2, and x plus y squared is equal to 198 minus 2 under 2. So for my right-hand side, 198 minus 2 under 2 is negative 4. And if I take the square root on both sides, I get x plus y is equal to the square root of negative 4, which is the same thing as the square root of 4 times the square root of negative 1. Now the square root of 4 is equal to, by the way, this is positive negative 2, and the square root of negative 1, if you guys already know, is equal to I. So these are two solutions, and these are imaginary solutions, by the way, not real. And now for my right-hand side, I have x plus y squared is equal to 400. So now if I take the square root on both sides, I get x plus y is equal to the square root of 400, which is positive negative 20. So these are two more solutions.